Hi, this is Mrs. Wiederholt, and welcome to my lesson video on rational exponents. Now let's get started. First, let's look at a list of rules that will help you when simplifying expressions with rational exponents. First, there should be no negative exponents. Next, there should be no fractional exponents in the denominator. The third thing, there should be no complex fractions. And the fourth, index of radicals should be as small as possible. Before moving on to the next list, let's go over this one in just a little more detail. By no negative exponents, that means you would need to use your laws of exponents or your laws for negative exponents to help clear that out. In the second one, no fractional exponents in the denominator, meaning you do not want a denominator that would look something like that. You don't want an exponent that's a fraction in your denominator. Now, a complex fraction is where your numerator is a fraction and your denominator is a fraction. And so you do not want to have any complex fractions. That would also go, you don't want to have, this would also be considered a complex fraction. Okay? So you do not want that. If your answer includes a radical, then you want the index of the radical to be as small as possible. And we will look at some examples of that just a little bit. Even though my last video covered simplifying radicals, I wanted to put this list here for you because this is just a good list, like a checklist, to help you make sure that you have totally simplified your radicals. First, there should be no radical in the denominator. Second, all powers in radicals should be less than the index. And the third thing, there should be no fractions under the radical sign. Let me quickly go over some examples of these. If we look at the first one, no radicals in the denominator, meaning you do not want a fraction that looks like this. You do not want a radical sign. Basically, all you want in your denominator could be a variable and or a real number. Okay? In order for a radical to be simplified completely, that means the powers inside the radical needs to be less than the index. So for example, if you have something like this, where your index is 3, and you have x to the 4th power inside the radical, you do not want this because that means you could say x to the 4 divided by 3 power. So this is not fully simplified. What you would want to see is something like this. This would be acceptable, where the power inside your radical is less than the index. And for the last one here, no fractions under the radical. And that simply would look something like this. You do not want the square root of x to the 2/3 power. Okay? That would be a no. When dealing with rational exponents, the laws of exponents will still apply. So now we have 4 different rules that we're going to look at, and we'll look at examples for each one. So now let's do the first one. In our first example, we have the cube root of x to the 5th power times the cube root of x to the 4th power. The first thing I'm going to do is to change this expression from radical form to rational form. So that means my first radical of the cube root of x to the 5th power would be x to the 5/3 power. And that will be times, and instead of the cube root of x to the 4th, that would be x to the 4/3 power. Okay? So now at this point, my laws of exponents go into effect. And if you look at the rule right here, when you are multiplying two variables with exponents, you add the exponents. So I'm going to add 5/3 plus 4/3. And so that will equal x to the 9/3 power. Well, I'm almost finished. 9/3 can be reduced. 9 divided by 3 is 3. So I can simplify this to x to the third power. Now let's look at the next example. I have the square root of a to the third power divided by the fourth root of a to the fifth power. Now again, the first thing I'm going to do is to take this expression and change it from radical form to rational form. So in my numerator, the square root of a to the third power would become a to the 3/2 power. And that would be divided by, and instead of the fourth root of a to the fifth, that would be a to the 5/4 power. Now I want to follow my rule for dividing variables that have exponents, and that means you would subtract the exponents. Now if we look over here though at our example, if you're going to subtract one fraction from another, they have to have the same denominator. My top fraction has the denominator of 2, and this one has the denominator of 4. So I need to make this one also have a denominator of 4, and I can do that by multiplying the numerator and the denominator by 2. So when I do that, this becomes a to the 6/4 power divided by a to the 5/4 power. And I can subtract 6/4 minus 5/4, which equals 1/4. So I have a to the 1/4 power. Now I'm almost finished, but since my original expression was in radical form, I now have an answer in rational form. So I need to translate this back to radical form. And so that means my denominator becomes my index. And so that means I'm going to have the fourth root of a, and that's my answer. Now my next example is going to be using the rule of raising a power to another power. And when you have an exponent being raised to another power, you multiply the exponents. In this example, I have the square root of x raised to the fourth power. And so that's the square root of x to the 1 times 4 power, which is square root of x to the fourth power. And so all you have there is the square root of x times the square root of x times the square root of x times the square root of x. Now, watch me on this. The square root of x times the square root of x is x. Again, the square root of x times the square root of x is x. And so basically I have x times x, which is x squared. And that's my answer for that one. This next example might be a little more difficult. It is the law or the rule of when you have a negative exponent. So first let's look at our example. We have x to the negative 1/3 power divided by x to the 1/3 power. Well, first we're going to use our rule of dividing variables with exponents, which means we're going to subtract our exponents. So basically I have x to the negative 1/3 minus 1/3 power, which is x to the negative 2/3 power. Now because my answer cannot have a negative exponent, I'm going to clear out that negative exponent by using that law. So I'm going to put this in the denominator, and the 2/3 becomes positive. Now I have a fractional exponent in my denominator, which I also can't have. So now I have to do what is called rationalizing the denominator. So I'm going to multiply the denominator by x to the 1/3 power. And I'm doing that because when I multiply variables, I add their exponents. So that means I would have x to the 2/3 plus 1/3, which is x to the 3/3, which is x. So that means I can rationalize my denominator. But if I multiply the denominator by x to the 1/3, I also have to multiply the numerator by x to the 1/3. So now my numerator is going to be x to the 1/3 power, and my denominator is x. And that's our answer. Now before we end this video, here are some helpful notes. First one, Give your answer in the same form as the original, even if you change forms while working it out. What this means is if your expression starts out as a radical, your answer should end in a radical. If it starts out as a rational, it should end as a rational. Second, try changing forms to help you get started. And that's what we did in every case of these examples. We changed our radical forms to rational forms to get started. And third, don't be afraid of fractions. They can sense your fear. If you are one of my students watching this video, will you please go to edmodo.com right now and take a short little quiz. I hope this lesson video has been helpful to you, and I look forward to working with you again. Bye-bye.